I'll figure that after. Okay, let's design Tinder. Design a dating app with swipe functionality similar to Tinder. Tinder is a dating app that helps people connect by allowing users to swipe right to like or left to bypass on profiles. It uses location data and user specified filters to suggest potential matches nearby. The functional requirements are users can create a profile with preferences and specify a maximum distance. Users can view a stack of potential matches in line with their preferences. Users can swipe left or right on profiles. Yes or no. 20 million daily active users. Let's just pretty much, let's just draw out the UI quickly. We have all the different people. I mean, you pretty much look at a photo of a person, and then there could be like multiple photos, right? And you can say yes or no. I think the interesting part, yeah. Let's see. Might be it's good. This one's gonna be good. So this is what the client sees. Non-functional requirements, probably availability over consistency when using the app. Like when they open the app, they need to be able to receive people and be able to swipe on those people. We should have consistency when it comes to matching specifically though. We don't want to match twice. I mean, yeah, we don't want to keep matching with the same people. Wait, see. Okay, availability over consistency when using the app. Support for concurrent users. Yeah, we definitely need to handle scale, but do we need to be notifying them in real time? Scale to support. Are they actually going to be concurrent? I don't think they're going to be concurrent. I think they're just going to be like dumb web clients that kind of will either request when they want to see the next 10 people that they can swipe on. Scale to support. It's not going to be like they're going to all be connected with a WebSocket or something. Consistency for matching specifically. Availability over consistency. And low latency for finding for consistency in the way if I reject someone or left right. I think consistency as in if we match someone, they're gonna know that we matched them. Kind of like we don't want some people like you don't want one person to think they matched but the other person doesn't know about it. Essentially, both users have to have swiped, and both users should be notified. Low latency, sub 300 milliseconds to generate feed for people to swipe on, and then feed should be infinite. Yeah, I guess. Yeah. I think this is a good set of things we have here. we should make it available so that when they use the app, they always have it. We have consistency when it comes for matching. So both users have to have swiped and both users should be notified. We should be able to generate a feed of people to swipe on um, with low latency. And the feed should technically be infinite. And yeah, data privacy and be able to scale. Nice. Okay, strong consistency when swiping. If user says yes on a user who swiped yes on them, they should get a match notification. Scale to lots of users, concurrent users, 20 million daily active. Load the potential matches, stack with low latency. Okay, we kind of hit everything there. Nice. I kind of arbitrarily chose 300 milliseconds, but I guess it checked out. Core entities. Okay, to figure out the core entities, we need to look at our functional requirements and kind of dig that out. So I just took a screenshot. So of course we're gonna have users, and users is gonna be we'll say profiles, where you kind of make your profile with all of your different interests. Then there will be different profiles. That'll include then there will be then there's going to be a matches. And there we're gonna be and for each person we're gonna want to store if we shown them to the specific. We're gonna need to store if we shown them to the date to that specific person. So we could probably store that all in matches. Stores like in our or what can we say if two people are shown both to each other? We can create one table for that, I think. We can say that it's like couples or something, or possible match or something. I don't know. Let's just say matches and pretend matches also contain if one person said yes, or pretty much will contain if one person said yes or not. I'm trying to see how we would model this. Do we need matches, or I think okay, since let's just like say there's gonna be matches, and then we're gonna show like this is hard to name potential matches. Oh yeah, interaction or something like that. Like we're gonna show, and then if they match, yeah. So we keep track with two profiles involved. Yeah, to no interactions, and yeah, we'll have a separate one for matches. Bro, thanks. What else do we need? Profile. Yeah, you're right. You're right. Nice. Yeah, they kind of have this like a swipe. Nice. They have interaction, and maybe the matches will contain the different interactions. So if two interactions happen, then it's a match. Okay. We need to keep track of these as well. So what are the different API endpoints we're gonna have? So we're gonna have let me do this. So let's just like copy our functional requirements down here. Oh, it doesn't even let us. But what we're gonna do is we're gonna have our different functional requirements right here. I'm just gonna shrink that. Just so we can figure out our API routes. Users can create a profile with preferences and specify a maximum distance. So we'll just do post. I mean, they'll be able to post when they're creating a profile. I think let's assume they already have the profile when they create it, when they do like a create account. So we pretty much have put profiles. Say description allows us to, like, we have a put request here that allows us to update profile. Header is the auth. Backend will decide which row in DB to update based on auth token. And then in the body, we could specify the different things like, yeah, we can change the age, range, etc. Age, range, other metadata. And then this should return us back our profile. So that allows us to create and then we can get feed just a, so gets a list of profiles. Do we need to support pagination here? Auth token. We'll still have an auth token so we can pick for, like, get the right ones, so we could figure out who to match with. Or do we need to do paginations? Probably. I mean, gets a list of 10 profiles. Yeah, we'll definitely need cursor based pagination, and this will return us a list of profiles. Do you mean put user ID here? Kubran? Do you think that there will be any security concerns if we allow the client to specify their user ID? usually the clients shouldn't. Yeah, like essentially clients should authenticate, and once they authenticate on the server, we should maintain a session, and in the client we'll just have a session ID, and essentially we'll pass in the session ID to the backend, and then the backend will figure out who the user is based on the session ID. So you can't fake that you're a specific user unless you hijack their session ID. But that's a lot more. That's a lot harder to jack, like a session ID. A session ID is harder to jack than a user ID, because pretend I start guessing people's user IDs, and then I just start figuring out. Yeah, user ID should be hidden on the session, and it should be hidden on server side. So pretty much when I say auth, that's kind of handling all that. Markel, what's good, man? I know a Jacob. I know a Jacob for sure. I have a cousin named Jacob. I don't know if it's the same one. I don't know his middle name either. Oh, yeah, I know that too. Then users can post. Um, let's say interaction. Um, so we say yes or no. Maybe we'll just do a body, and we'll say profile ID of the person. How does it change your design? That's going to be later in the deep dive. So not users can swipe left or right to express yes or no to other users, and users get a match notification if they mutually swipe on each other. Okay, I think this hits all of our requirements here. Damn, what did I forget? Oh, shoot. So get. Okay, we didn't pass in query parameters. Yeah, we just didn't pass in query parameters. Oh yeah, this needs to be by lat long. Do some deal hashing stuff. What else? And we'll figure out the preferences in the back end. But oh shit. Okay, we're getting to high level design. How will users be able to create a profile and set their preferences? So we're probably gonna have a client here. Obviously, these are usually phones. we're gonna have an API gateway because we're probably gonna want to separate our service for updating or for updating preferences from the service that like our reads and writes should be separated because our read service is gonna handle a lot. We could probably to simplify it. We'll just have a simple app server. And then we have our simple database. So Markel, like what time is it for you? I don't know, man. I just like to do this stuff. 3 p.m.? I don't know. Usually from 9, I drink a lot of coffee. That's one thing I do. So how will users be able to create a profile and set their preferences? So users will be able to create a profile by pretty much using the post request to create their profile. Like there's probably some sign up form where they'll be able to sign up, or they can sign up using Google or something, and then we could do OAuth. But essentially, let's just assume that profiles are already created. In order to update their preferences, they're going to make post requests, and the API gateway is going to route that post request to our app server. The post request is going to grab the body of the app server is going to grab the body of the post request and parse out the details, such as the preferences they want to update. It will generate the query for the insert query to the database, or for the database, and insert it to the database, and then return to the client 200 if it's successful, 400 if it was malformed, 500 if there's a server error, like all the general stuff. But that's kind of the data flow. What happened? How did I get... Where's the feedback session? Nice. How will users be able to get a stack of recommended matches based on their preferences? Okay, this is a bit harder. Um, one sec. Let me set up my dinner real quick while y'all think about this. How will users be able to get a stack of recommended? Like, this is a very interesting conversation. I think in the interview we'd probably spend a bit more time on this. I'm gonna eat some Trader Joe's. Tonight, where are you based? Eating healthy. Sick. Do you work right now? Mike, it's good. Yeah, internships count, bro. Yo, what are y'all thinking about? Everyone drop in the thing how they think they're gonna figure out the matches. Whoa, Pabron. Seems like he knows what he's talking about. Pabron, like, figuring them out on the fly is possible, but it introduces a lot of latency, right? It's still, I know what you're saying. I know exactly what you mean. There's two ways. We can pull it and we can figure out on the fly, or we can pre-generate it. What do others think? But yeah, I think your approach there makes sense. I was thinking the same thing. But Baron, can you be more specific on how you're gonna generate this cash? Like where is this cash gonna exist? Who's gonna write to this cash? When is that cash gonna get updated? Can you be more specific? That takes the user. So what is it gonna do? What do you mean it's gonna take the user database? Could you write it out? Be more specific there. Okay. I'm gonna go with your approach here, and we're gonna have a Redis cache. Right? So we're gonna have a Redis cache, and in our Redis cache, we're going to have a queue for all the users, by user ID. So we're gonna have a queue for each user ID in our Redis cache, and essentially when the client wants to grab the next, let's say they want to grab the next 10, they're gonna just grab it from this Redis cache, right? Oh, I skipped ahead. So when they want to grab it, they're gonna grab it from this Redis cache. Let's see. Wait, let me just reply to someone. right? Let's say, what, like I haven't really used Tinder, but I've seen how it works for people, and pretty much there's a predefined number of swipes that they get a day. Right? So they get a predefined number of swipes a day. So I think what we need to figure out here is what we need to figure out here is how we're going to populate this cache. And what we could do is asynchronously, we could have like a async job, like maybe Lambda functions or something. Kind of like cron, whose job is to populate the swipes for a specific user for a day, right? This is happening asynchronously. So pretty much the Lambda function connects to the database. It could be talking to some ML service. Like there could be some ML service, right? But what the Lambda function is going to do is going to talk to both the user, our regular database, and our ranking service, and essentially generate a list, basically generate the swipes for a user for a day. And while it's generating that, it's going to be populating this Redis cache asynchronously. This is kind of annoying. Right? So we have the Lambda functions that populates the caches async, and it can use like a ML ranking service. It'll see people that are nearby. Yeah, it will basically query the database to find people nearby, maybe through geohashing or something, and then also query if you already matched with them and stuff. And also make sure you didn't match with them. After that, it's gonna pass it to our ML service that's going to rank them, and then from there, we'll populate this Redis cache asynchronously, right? And then store the interactions in the DB, so that so now we're kind of keeping it in now, but we have a consistency problem, right? So maybe we could probably get rid of this Redis cache and we could just store it straight in the DB and have interactions and a cursor to when that interaction was generated. So we don't have a consistency issue, or we don't need to deal with consistency between our DB and Redis. But we'll talk about that later. Purbaran, how does that sound? I think consistency here is important. And sorry if I'm completely saying your name wrong. And where are you based? Oh, nice. Thanks for connecting, bro. Legend. 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 Thanks for tuning in, bro. Okay, how we used to be able to get us. Okay, so what we're gonna do is so to get the recommended matches, there's two approaches here. We can either when a client is finished with looking through their potential swipes, and they either swipe no or yes on all the ones that we've already sent to the client, they can make a GET request to our service, and we can eventually figure out what are the next matches or what are the next set of matches that or interactions that we want to show this client. But that can be really slow. It can be have a lot of latency because we're gonna have to do a bunch of queries on the fly. Maybe talk to the ML service on the fly and figure out the best ranking for people we should show them. So what we can do is actually just pre-generate all of the interactions that we want this user to have, and we could pre-generate it asynchronously using like a Lambda cron job that populates a Redis cache, and the Redis cache will have keys for every user. So pretty much when a client asks for the next set of interactions, it will ask the server, and then it will just pretty much pull from the queue, first in, first out. And yeah, we'll have the Lambda's functions actually pushing onto that queue. The Lambda function will have access to the database, so it'll know who you interacted with already. It'll know your preferences, and it'll be able to like perform geohashing to filter down people who are close by you. Then it'll be able to pass all the profiles near you to a ranking service and figure out who should be the next like 10 swipes or something like that. Or yeah, the ML service will essentially rank people, and yeah, basically it'll populate that Redis cache. Got you, bro. Are you on the Discord? Bro, go on my profile. I can't send the link right now, but go on my profile on YouTube, and you're gonna see the Discord link if you go on my profile right away. Because it won't let me even send that. Or every time I go on Discord while I'm streaming, it like doesn't let me pass the link. So this is very efficient and will improve in our deep dives. So they're kind of just saying like a naive approach as well, which is just like on the fly per run. But honestly, we shouldn't save it for the deep dive, because what if the interviewer just thinks we're overlooking something, right? I think they're just doing that, but that's not really. I think in terms of interview, you should just front load that before they start thinking you don't know what you're talking about. Yeah, this is like a basic playbook answer. So users, so pretty much the client side will have a list of interactions. Essentially, we'll have a list of profiles that they're gonna say yes or no to. For every profile that they say yes or no to, we have access to the profile ID client side, and we'll send a post request saying we basically saying yes or no for that specific profile, right? Um, Pretty much when they send the post request, the app server gets that post request, and then we'll probably first check a couple things. Yo, Caesar, what's up? We're designing Tinder. Yo, did you just get home? Oh yeah. Oh yeah, Caesar's here, so he knows how Tinder works. So we're gonna talk about this. I'm swiping right. Pause. So basically, this is what we're doing. We have a Tinder. When we have a bunch of profiles, you'll say yes or no to each one. Let's go back to our non-functional requirements. So our functional requirements are pretty much users should be able to create a profile, specifying their age and their interests. They're essentially like to say the different things, like the things about themselves, like if they're 6'2", like pretty much all the things related to their profile. So they should be able to create a profile, and then after they create their profile, they should be able to get a news feed, or basically a feed of people who are nearby and might be a match for them, right? So then they're gonna swipe left or right on each of these specific people. Shabbat, nah, I can't. I don't want to make money off my thing. I don't want to monetize it yet. It's against my visa, basically. So, essentially, yeah. Once on the client side, we're going to be able to say yes or no on specific users, and if both of them say yes, we should notify them both that there's a match, right? So that's kind of the functional requirements. I'm pretty sure y'all have used Tinder before or some sort of dating app, but our system needs to scale to 20 million active users. Shabaj, yeah, it sucks, bro. It's all good. And okay, what I also mentioned is we're gonna prioritize availability over consistency for the app. Meaning, I mean, actually, that part doesn't really matter. But essentially, when we use the app, we just need to. Essentially, when they use the app, they should be able to see profiles and stuff. It should be highly, like the uptime of our service should be up, or like 99.999999999. But then also we need consistency when it comes to matching. So if two people match, we need to make sure that's highly consistent, as in both users should have swiped in order for the match to have happened, and both users should be notified, right? So that's another non-functional requirement. Another non-functional requirement is that when someone loads up Tinder, it should generate them a feed of people to swipe on very, very fast. It shouldn't be slow. It should be under 300 milliseconds. Um, Feed should be infinite. I mean, that's not really the case actually. Like usually people have number of swipes per day, right? So feed should be infinite. Probably not. Feed should be finite, unless you have premium, right? And then maybe we can buy more swipes or something. Um, Data privacy, we don't need to. We need, obviously that's the case with most apps. Scale to support 20 million. So that's kind of our non-functional requirements. Our core entities, and Alpha, welcome back. Our core entities are profiles. So we need to, in our database, we need to have a table for our different profiles where we'll include all the people who created accounts and metadata that they submitted, like their location, their height, their weight, their preferences and stuff like that. I mean, they don't add weight. Um, that would be crazy. But pretty much we'll have a profiles table. Then we'll also store the interactions, because we need to know the different interactions with the different people. We need to know who you said yes and no to, right? And eventually, if two people say yes, so two interactions are yes for like two people, we're gonna generate a row in our matches database. So we have simple API endpoints for updating your profile. So from time to time, if you want to improve your profile, maybe you're not getting the matches that you like, or maybe people are passing up on you too much. You're gonna tune your profile and hopefully get more matches. So you need to hit this put endpoint, which allows you to update the profile. So yeah, you can update your profile, and then we have a get endpoint that essentially what it's gonna do is you're gonna, every time you do a get request to the feed, it's gonna generate you 10 new or it's gonna give you 10 new profiles, and we're gonna do some sort of pagination there, maybe cursor based pagination. But essentially, we're just gonna return 10 profiles at a time, allow you to swipe through them, allow you to look through and see if you're interested in this person. And then after you're like maybe when you're at like the 8th or 9th profile, we'll do another get request to get 10 more profiles so that it seems like you have like an infinite scroll. And basically when you're on each profile, if you say yes or no, we send a post request for that specific profile ID you said yes or no to, and we're going to store that interaction in the database. That's kind of our data model. And this is does that make sense so far for the data model, everyone? Okay. And as Pubaran was saying before, one of the non-functional requirements was under 300 millisecond latency when it comes to generating a list of interactions. So, I mean, there's two ways we can do this. We can do a pull model or a push model. The pull model is when the client pulls for the next set of profiles. I mean, they'll always pull, or basically the two options is generating the interactions on the fly, or pre-generating them. So on the fly would be, pretend I'm a client and I exhausted my swipes, so I make a get request to my database to get the next 10 swipes. Essentially, what we can do is when they do that get request, we can query the database to figure out who should be the next 10 people we send this user. And pretty much query the database for that. Make sure that this person didn't already match with those people, or that person didn't already say no to those people. And we could do that when the client makes a request, but that latency is going to be high because imagine we have to query the database, and imagine we have to talk to some ML service to rank the results before we return it to the client. That's definitely going to be over 300 milliseconds. So the approach that we came across with is pre-generating the list of interactions that we want to show a user and storing it in some Redis cache, where the key is like a user, and they're going to have a queue for the interactions we want to show them. And we're going to have an async Lambda function that's going to be populating their queue. So probably periodically, maybe every day, it's going to query the database to see possible interactions that they never had before. It's going to pass those interactions to the ML service to rank them, and it's going to populate the Redis cache with the different interactions. So that's already going to be pre-generated. So now when a client asks for their next set of interactions, we don't have to figure that out and create a database at all. Since we're using Redis, everything is pretty much in memory, and it could just pull from the queue here and send it back to the client. So that will allow us to hit on sub 300 millisecond latency, and allow us to be smarter with how we're generating the interactions, because then we can interact with an ML service that might be slower. So how will the system... Did we already answer this? Okay, so how will the system register and process user swipes? So, let's see. We have to refresh this. Everyone following along so far? So on the client side, after we did the get request to have a list of possible interactions, we're going to the interaction ID is going to have like a profile ID, or the client side is going to have a list of profiles that's shown to them. And when they swipe left or swipe right on a specific person, we're going to send a post request to our app server with the profile ID and yes or no. And essentially, what the app server is going to do is it's going to um, what the app server is going to do is it's going to pretty much see if there's a match here. Basically, what it's going to do is create a database and see if there's an interaction for the other person, and both of you essentially swiped yes. Because if it did, what the app server will do it will automatically do it like a 200 success to the client and tell them that they did a match. And maybe we could have like a notification service where we push notifications to, and it'll eventually, we have a notification service, and we have another other client. So what we can do is we can, if we see that two interactions lead to a match, we'll actually insert that into our database, notify the client that there's a match, and then also push to our notification service. And we'll have a notification service, and that's kind of abstracted, whose job is to notify the other, like send a notification to that other person that there's a match. And it could do that using push notifications if they're using like iOS or Android. So yeah, we'll generate the match there. Oh, sorry, I already went over the 2 minutes here. Nice. Would you use the ML on images here for describing profile? I don't know. I don't think this question really needs to, like, we can involve ML wherever we want to, but I don't think this question specifically needs it. Like, even this ML ranking service is a bit like over. When a user swipe, they'll send a post request. The service records a swipe. To detect matches, the swipe service will check if there's a corresponding right swipe from the target. If, yeah, like as we mentioned, if it is, we'll create a new entry in the DB and also create a match. But then we also need to notify the other client, and we'll let the notification service handle that. Okay, I jumped ahead. The other users needs to know a new match as well. So essentially, when the client sends a post request to saying yes, what the app server will do is figure out if that other person that they just said yes on also said yes. If they did, we'll create a match in the database. We'll create a new entry for a match in the database, and then we'll also push to our notification service that this match happened. And the notification service is a bit abstracted to us, but essentially, if we just pass back the profile IDs, it's gonna know like how to send the notification to that user, and it'll probably do that using push notifications, like Firebase for iOS, and just regular Firebase for Android, and whatever iOS uses in order to send push notifications, but we'll have a separate notification service for that. Maybe this notifications service will have like some Kafka queue that we can push to so it doesn't drop requests. And then we have different consumers that kind of consume from the Kafka queue and send out those notifications. Let's see. Yo, we're destroying these system design interviews. Markel, thanks. So there's a notification service. It'll publish a message to the message queue. The notification service consumes these messages and sends push notifications to both matched users. Yeah, using Apple notifications or Firebase. Yeah, that's exactly kind of what we said. How would you design the system to ensure that swipe actions are processed both consistently and rapidly so that when a user likes someone who has already liked them, even if see. This is a good question. I feel like that's what the database is for, right? Let's see. Like if we use a SQL data, I could see if we use a SQL database here, it will be strongly consistent. So basically, when we read the database to look for interactions, look to see if the other person said yes, we're gonna see that right away. So I think um, like we're gonna need strongly consistent reads because what we don't want to do is pretend somebody did interact with us and like us. What we don't want to do is read a stale replica of the data and think that they didn't say yes to us, and then we don't generate that match, right? We could refresh the cache and add that user in the list. I think Purbaran, like the main thing when we're dealing with a database and a cache is um, now we need to maintain consistency between the database and the cache, and that leads to a lot of synchronization issues and a lot of synchronization stuff that we have to handle in the application layer. So we don't. So if we could avoid figuring that out by just doing strongly consistent reads on the database, I think that's going to be the better approach. Let me know if that makes sense. Which latency are you worried about? Well, this is gonna be like a microservice architecture where we'll have a match service, and then we'll have our feed service. So for figuring out the feed, um, we could just talk to this service directly. So that system is kind of independent of what we have here. And for matching, we could just make sure that matching only handles logic related to matching, and we'll just need strongly consistent reads on the database here. So I'm just gonna say that. How would so pretty much to design our system to ensure that actions are processed. Essentially, we're gonna need to worry about is our database reads being strongly consistent or not, because like I mentioned before, our match service, when somebody says yes or no to someone, our match service is going to do the job of looking into the database to see if that other person also said yes on them. And if they did say yes, we're going to generate an entry into the database saying that there's a match there, right? So we need strong, consistent reads, and we could achieve that using SQL database, or DynamoDB even has strong, consistent reads. But essentially, what we can do is like, because essentially we don't want to read stale data thinking that person said didn't reply yet. When we read when like the second person says yes, we need to read the most recent copy of the database across in a consistent manner and be able to generate the match. So yeah, pretty much the match service is going to handle that. We're going to do strongly consistent reads, and if there's two interactions that said yes, we're going to generate a match and then send it off to our notification service. Damn, that was a mouthful. Damn, they didn't like it. What? They're using Redis. I see. Yeah, they use Redis for it as well. Afzal, got you, man. I'll do that in the morning. I think that these. Afzal, how you been though? Yeah, okay, they use Redis. In memory. To ensure both consistent. We'll store each user's right swipes in a Redis set using the user ID as the key. We'll use Redis atomic commands to add the target's user ID to the set and immediately check if the target user has already swiped on the right on the current user. Shabazz is good. Yeah, you could use it for everything. Okay, yeah, we pretty much just like offload it to Redis. I guess like since it's in memory, it's gonna be a lot faster. Whatever. Take an L there. Bro, we talked about this already. What is it talking about? Okay. Perberon, how can we improve this though? Do you think there's a better way to do this? Before I... How could we generate this news feed in a better way than a Lambda function? So you might want to add the right swipe part. Let's see. I see, I see, I see, I see. So how can we generate this? So we have our feed service. Our feed service. What what we can do here is instead of a lambda or something, what we're gonna do is we can tell like the feed service will have a queue, a Kafka queue that it writes to. So this could be more event driven. So essentially what's going to happen is as somebody asks for a feed, this adds a bit of latency here, but essentially when they create a profile, we'll generate them a list of their feed, right? And essentially when pretty much what's going to happen is when the feed service sees that somebody's queue is getting low, it's going to push a job, basically push a job that will tell like a worker to generate like the next batch. So that's more, it's event driven. Workers. Bro, so it's gonna be more event driven. So in order to have low latency um, feed generation, what we're gonna do is pre-generate the feed. So we're gonna have a Redis cache that maps user IDs to a list or a queue of all of the different interactions that we want to show them. It's in a first in, first out manner. So we're gonna have a separate job that populates this Redis queue, and that separate job can happen based on specific events. Specific events could be like the client just signed up, um, or we could push events such as the users the user has like is running out of interactions, or maybe the user paid for more interactions. So essentially, based on different events, we're gonna push to a queue, a Kafka queue, and there's workers in charge for generating feeds, and they're gonna get events. Basically, the events will just tell them that we need to generate a news feed or a next set of interactions for a user. And yeah, it will talk to the ML service for ranking and stuff eventually, or essentially, and yeah, look in the database to see which interactions are actually valid and who they passed to. Make sure we don't give them people they already matched on. But yeah, kind of we abstract that away. We just have workers that will populate this Redis cache, and these workers will receive events, and there's going to be different events like somebody signing up for the first time, someone paying for more swipes, someone's swipes are getting low, maybe it's a new day and it's their first time logging in. That's kind of how we'll push things to people's Redis cache. But what? Yeah. Even when new people sign in and stuff, I don't even know. Okay, they're using a hybrid approach. When they first join, so we have a cache, and then while they're swiping, we'll deliver like fresh, relevant ones. Interesting, interesting. Showing users. How can the system avoid showing user profiles that users have previously swiped on? So we can basically our database is gonna be storing all the different interactions, and what we could do is we can index those interactions by profile ID, so we can easily see um, we can easily we can have an efficient query to find all of the basically when we want to show a list of the next list of interactions, we can easily query the database to see who, if any of these profiles we didn't interact with. And also, yeah, basically when we're looking for profiles to send. Actually, let me think about this a little. What do y'all think? What do y'all think? This one's a little bit more. And I'm probably out after this. What do y'all think? I'll load interactive user ID. What does that mean? Oh, I see. Like load it into memory. So you can quickly see. What about just good indexing? But yeah, it's gonna be a lot of load. Yeah. You're right. You're right, bro. You're right again. How you always right, man? How can the system avoid showing user profiles? So yeah, what we're gonna do is, as we mentioned before, what's gonna be happening is we have our Redis cache that's gonna be storing a lot of our interactions, and yeah, essentially, we're gonna we're gonna know the interactions that are happening, and we're gonna have them in memory, so that when we're trying to generate the news feed or the feed for that specific person, we could easily quickly see if any of the interactions that are in the list we want to show them are is this still good? Yeah. I'll get to that. I'll do that as soon as I finish this. Do you want to hop on the voice chat on that? Let me restart this. I'd rather do it on voice chat, bro. Yeah. So essentially, what we're gonna do, I mean, there's two solutions here, right? It's either we index our interactions well, so that um, there's gonna be a lot of database calls, but we're gonna make sure, like, we're gonna add the proper indexes so the database queries are more efficient. So that's one way if we just want to manage it in the DB. But if we want to reduce the load on the DB and make things faster because it's going to be in memory, we can use Redis. Redis is going to pretty much have our interactions stored in memory, and when we're generating a feed of interactions we want to show somebody, we can look in the Redis cache to make sure that we didn't already show them this interaction. So this is so this is essentially how we do things in memory. We can either use Redis to cache all that and reduce DB load, but if we can't, if the interviewer wants us to, um, yeah, we can just index the data in our database as well. Alpha, is that what did you? probably gonna get a trash response here. Or like my answer here is trash. Okay, it's all good, bro. So damn, I'll probably maybe do that tomorrow. First, for users who we maintain a server-side cache of their swipes. Nah, bro, I just post one video a day. That's kind of how I grew it. When storing, checking a full list, we'll implement bloom filters. A bloom filter is a space efficient. Okay, we're using bloom filters. Okay, what the? I don't know anything about bloom filters. Okay, I guess we're gonna use bloom filters. Nice. Got through another one. I'm gonna read that solution more deeply a different time, but yo, we got through a lot of these. Okay, what was kind of interesting about that problem? Bloom filters, obviously. Consistency on swipes and not showing a user. Consistency on swipes and not showing a user you already answer. Here's bloom filters. What else? What else was interesting? Pre-generate. Do we want to pre-generate feed or generate for each post request? For each. Markel, I don't know either. I'm gonna have to look it up. What else was interesting? I'll probably just read an article on it. But yeah, you could probably just prompt GPT. That's probably faster, more efficient. Okay, let's do that resume review.